day, everyone. Today, we are solving polynomial equations. Now, I do apologize because we did do this lesson on today, September 6th, and then we did it um, yesterday, September 5th. So, we did this in class already, but this is just a video coming out. I do apologize about that. My technology been giving me some serious issues. So that's lots to cover. So let's just move on. Alright, in this lesson, solving those equations, factor, and radical methods is what we need to do to solve equations by factoring. Announcements. Alright, we will start ACT prep this month. We will be using our Eureka book for challenge practices. We will be having 3 quizzes this month. So you're gonna be having quiz back to back, back to back, back to back. It's coming. So be prepared. And the quizzes may be a little bit shorter too. So any assignments that was not turned in by the 1st of September, guess what? I'm no longer accepting it. After today, I'm no longer accepting J Campus. Reminds bonus points. So I can't really do nothing for you on that. So you have not downloaded the app. Well, can't do you nothing. Alright. Remember, unless you have documentation of your absence, you are still responsible just like everyone else. So if I post the homework or whatnot and you was absent today, you still gotta do it. Again, you have to bring documentation to get things done. So if you guess on it, that's fine. But I need for you to do the work still. But if you say you come in next day, I need documentation. You need to have documentation for me to look at so I can take care of it. And make a work to give you your extended time. Makeups are only for the month of September. So anything September related is the only thing that I could allow. Now I may allow ANET and Illuminate if you have not done so already. Algebra 2 will be done differently. Y'all please be prepared. It is going to be a difficult course. I need for you guys to be at your best. Pay attention to the tutoring dates. Reminders, Algebra 2 does demand a lot from you. It does. There's no way around it. Many of you guys who are not studying, that's what's going to do you in. Big time. Alright, stay ready so you don't have to get ready. Be about your business. Due diligence. Self-avocation. So when you got, talk about a problem, do it the right way. It's easy to flash, but when you flash, you get in trouble. Self-accountability. Respect for the learning environment. No compliance hinders academics. Y'all, please put your phones away. I don't want to take them. That's not me. But please, y'all. Your grades reflect everything you do, so you always on your phone, not really always putting them up. Guess what's eventually going to happen? Your grade's going to soon, hit. Alright. Y'all, I also ultimately recommend where you go. So if you, did poorly, failed Algebra 2, I decide that I want you to take the course again, or do I send you an Ingenuity? But y'all, please, please, please don't make the mistake that Ingenuity is the easy way out. I promise you it's not. I promise it's not. Get right the first time so you don't have to go through all that. The instruction piece. We will take time, but I can't take forever, y'all. I can't. I can't take multiple days. I always review what we did previous class. I always could include that in my work, but I can't do no more than just that. All right. When you're doing groups, y'all, don't ask me if this is right or wrong. I'm not going to answer your question. I may ask you another question, or I may make you run, or I may run circles around you by asking you a series of questions to make you think of something else. I need for you to stand on your own. All right? Y'all, sometimes we're going to have to do problems on the board, and I know in this class period we will do just that. Be kind regardless. Without homework, you cannot pass this course. Without studying, you definitely won't pass this course. Bring everything to these problems. All right, so y'all, what you see here is some stuff that they say about Algebra 2. I'm not going to tell you, I'm just going to put them up there. You just take your time to read them, of course. These are what students say about Algebra 2. This is all across the whole United States. So this isn't just a Louisiana thing or a Struma thing. This is all over. Review factor. All right, so we talked about this in class for those who was here. So this was also on your quiz, and you probably gonna see something of that caliber again. But again, just do the right thing. So let's do this. So we know this is a trinomial. We know the word trinomials. However, this is a unique trinomial because you have a number in front. Anytime you have a coefficient in the front, a coefficient in the front, coefficient in the front, coefficient in the front, you going to have to do some unique methods. Either it's going to be swing or other things, but in this case, we know that 6, -18, and 12, they have something in common. They all have a 6, but also because you have variables with exponents in all terms of the trinomial, we know that they have at least a x squared in them. So x4 has an x squared in it, x cubed has also an x squared to it. So my greatest common factor, which we just found out, was just 6x squared. What's left? Remember what I showed you in class. You're going to take this and you're going to figure out what times what going to give you 6x to the power of 4, gives you negative 18x cubed, and what's going to give you 12x squared. So you have to figure out those factors. We multiply by 6x squared. And when we do that, we get this. So we get x squared minus 3x plus 2. Because when we multiply all of these together, we get this. We multiply all of that, we get this. When we multiply all this, we get that. So when we multiply, just like I tell you guys, you should distribute the property. So when you multiply, you do what to exponents. You add them. All right. So with that being said, so let's move on. Now, we got to factor what's inside the parentheses. So what two numbers multiplied together gives you 2. What numbers multiplied together gives you -3. So -2 times -1 is 2, because two negatives makes positive. -2 plus -1 is -3. Put everything into factor form, including the greatest common factor, and that's it. That's all you have to do on that. Many of you guys freaked out because you was like, "Well, Mr. Howard didn't do a problem like this, so why I have to do that?" In a math class, in this class, you're going to fail with thinking, "Oh, it got the test got to be exactly what was taught in the class." Exactly. That's not the case. It would never be the case. Math is learning material by applying stuff that you have already learned in the past. Without that stuff that you have been taught in the past, you can't bring it out of you somehow. You will fail this course. Keep that in mind. Let's move on. Solving equations by factoring. So we already solved our equations. You guys are pretty good with solving equations. You guys are not bad. I seen you in class. I was cool with it. All right. So here I go showing you what to do. So your first step in this binomial with a leading exponent of 2, find your greatest common factor, which we know in this binomial is going to be 12x. That is your greatest common factor. So what's going to be inside the parentheses is x plus 3. So it's 12x being the greatest common factor times the factor itself, x plus 3. Next step, set your greatest common factor and the factor to equal 0. And the reason why you're going to do that, because this is the only way you could solve an equation, because we had to turn the greatest common factor and the factor into equations so we could figure out the solutions. So that's why we set them all to 0, so we could have an equation, and so therefore we could solve it and have the solution. So let's do what's in the left. So that 12x is understood to be multiplication. And we know the inverse of that is going to be 12 over x. And I'm sorry about that. I am drawing with my finger. So forgive me on that one. So 12x is the inverse of 12 over x. So we are dividing. And we know 0 divided by any number is 0. Right? X plus 3 equals 0. Well, we know just subtract 3 from both sides, and that's our answer. And when we say the solutions are x equals negative 3 and 0, another word for solution is 0. Another word for solution is 0. Another word for solution is 0. And you got to always go from small to largest. All right, let us move on. Your turn. You try. Now, pause the video, work it out. Pause the video and work it out. Pause the video and work it out. Welcome back. So let's see how you did. Did you find the greatest common factor? Did you rewrite it in terms of having the greatest common factor? Oh, and the factor, I'm sorry. Good job. If you did you set the greatest common factor and the factor to 0? If you did, awesome work. And you know when you saw the first equation, did you get 0? What about the equation to the right? Did you get negative 7/3? If you did, you are a legend. Good job. And remember, solution, the other word for solution is 0. And we're going to dig more into that throughout the 9 weeks to discuss the zeros and stuff like that. All right, here I go doing this problem. So by now, you know a perfect trinomial. You know it so well. By now, we know when we are factoring this trinomial, we know we gotta figure out where two numbers multiply together gives me 6. And we know when we add them, God gives us 5. Alright, 3 times 2 is 6, 3 plus 2 is 5. Put them in factor form, and then just set each factor equal to 0, and then solve. The equation on the left, when we solve that, we're going to get negative 3. But when we solve this one, the one to the right, we get x equals negative 2. And so our solutions, or zeros, are negative 3 and positive 2. And do not forget to have it in this particular order. Negative 3, negative 2. Negative 3 is the smallest. Positive negative 2 is the largest out of the two numbers we have. Alright, let's move it along. Uh-oh, you fist a try. And it's going to become a little unique. There's going to be some stuff that you're just going to have to figure out. Alright, so do this problem instead of by yourself. Do it with me. Alright? Do it with me. So pencil ready? Set? Let's do it. Step 1. Because this is a trinomial that we know, find the greatest common factor, which we know is going to be 6x squared. And then we're going to rewrite the inside, which we know is going to be x squared minus 3x plus 2. And we know in order to check our work to make sure that we are correct, as I have told you previously, just use your distributive property. Again, y'all, I'm writing with my finger because I cannot find my stylus. You know exactly what those squiggly lines means. If not, go back to this problem that I did and just try it again. Alright? By now, because you are such a legend, you already don't start, factoring the inside of the parentheses, trying to find out those winning numbers. Or where two numbers gives you positive 2, but when you add them, it gives you negative 3, which is negative 2 and 1. Negative 2 and negative 1 is how I'm winning numbers. Now, we are put in factor form. Good job. Including the greatest common factor. Now, we gotta break this apart. So we're gonna rewrite each factor and greatest common factor into equations. So we're gonna have 3 different equations. What we solve to the left is gonna be what? 0. And then the middle one's gonna be negative, positive 2. And the last one's gonna be positive 1. Good job. And again, if I'm going too fast in this, you slow down. Slow down by rewinding the video. That's the reason why I'm making these videos, so you can get what you need. Because you may not get it in one swoop. But I do want to ask you an essential question. So, usually, when we are looking at the leading exponent, that usually is an indicator about how many solutions we have. We start out with, we're supposed to have 4. Why do we end up with 3 solutions instead of 4? Well, because this situation right here becomes one solution on its own, becomes just 0. And there's some additional details that I'm going to talk to you guys about. such as repeating zeros, but we ain't gonna worry about that. I don't want you guys to know about that at this moment. But we have 3 because x equals 0. These right here are just 2. So let me explain in detail right quick. So usually, looking at this problem, when we factor this, we know we're going to get x plus 2 and x plus 3 as our factors. And here's my point I'm trying to make here. When you set both of these to 0, you're going to get x equals -2 and -3. And again, those are 2 solutions, right? Or 2 zeros. But we know this because our leading exponent usually tells us how many solutions we will have. And usually it tells us 2. But sometimes that's not always the case. Alright, so let's move on. Alright, your turn. You try. Pause the video, pause the video, pause the video, and try it yourself. Welcome back. Let's see how you did. What you did. Alright, so did you find the greatest common factor? Which was what? 5x to the power of 6. Don't let those exponents get you. When you pull out the greatest common factor, make sure you go for the smallest exponent. And when I rewrite it, I get that. Again, use distributive property at this step to check to make sure that your work is correct. It's not mandatory, but it's just a good habit again to show your work. Moving on. So now we can worry about the inside of the parentheses. So let's find out when the numbers, when they're multiplied together, gives me -4. And then when I add those numbers, it's going to give me -3. -4 times 1. -4 times -4 times 1 is -4. But -4 plus 1 gives me -3. Alright? So set the greatest common factor. And the other factors all to 0. Good job. Good job. And let's just solve for x. So the first one we know is going to be 0. Second one is going to be +4. And the third one is going to be -1. If you did all of that, awesome work. But if you are struggling with this, please go back to the previous example that I had worked before I start talking about the number of solutions you usually have. Again, if you are struggling through this, please review the previous problem that I just did before I discuss the typical number of solutions. I'm going to say it one more time. If you are struggling with this, rewind to the previous example I worked before I have spoke about the typical amount of solutions you have. Moving on. Alright. Again, what determines the number of solutions? Usually it's the leading exponent tells you the number of solutions. That's not always the case though. And the word for solution is 0. And also in this lesson we're gonna probably know another word that means the same thing. Alright, now we gotta solve equations by other ways. Uh-oh. You need to take yourself a break, get you some water, come back, because it's about to get real messy up in here. All right. Before we get into this second part of this lesson, we need to know this. The inverses of x to the power of 2, you're going to rewrite it as the square root of x. All right? That's all you need to worry about. The rest of this other stuff is the second bullet point. You don't need to worry about that at the moment. You're going to see that definitely again towards the second semester of Algebra 2. All right. So, yeah, let's have ourselves a discussion. Here, when you are solving the polynomial equations, you will have either plus or minus, because usually this refers to a quadratic. So this refers to the exponent of 2 type problems only. Alright? So you guys, when you're dealing with problems with the exponent of 2, if the square root is positive, then it's going to be one or the other. Or it's going to be both plus or minus. But if it's negative, if the number is negative in the radical, then it's not real, it's imaginary. For example, if you go to Google and you type in 4 negative 4, you're going to get an error message. Or it's going to say something like plus or minus 2i. And they're going to write the I like that. They write that I like a backwards J. This means that it's not real. It's imaginary. Then negative I, well, let me say this. The negative 1 is replaced and rewritten as I. So let's do another one. Negative 36. Again, if you put this in the calculator, you're going to get error. It's going to become 6i. Don't forget it's plus or minus. Because negative 36, we know the square root of 36 is 6. Alright? Again, I means that it's imaginary, it's not real. So the words roots, zeros, and solutions all mean the same exact thing. There's slightly any difference. Alright. So when you solve these equations that we're about to see, it's going to have if it is positive, like say 64, you're going to have plus or minus square root of 64 is 8. That's when a, the number we chose to be positive. But if x equals 0, the square root of 0, if the 0 is in the square root, guess what? You're just going to have one solution of 0. If a is less than 0, like negative 4, it becomes plus and minus 4. And that negative sign, you're going to rewrite that as I. And you're going to write your I backwards. Alright, so let's get on through it. Alright, here I go. I'm going to do this problem. So take notes. So here, We know how to solve this. So that, remember, before I continue, remember your goal is to get x by itself. Get x by itself. Get x by itself. And to do that, you gotta do the opposite of things. So your first step, that positive 49, turn into a negative 49. Your next step, after you have taken, after you have made it negative 49, take the inverse of square. So as I told you earlier, x squared, its inverse is going to be the square root of x. So take the square root of both sides. So let me ask you this question. Can negative 49 be in the square root? Can I have a negative number in the square root? No. But I know the square root of 49 is going to be 7. But because it's negative square root of 49, it's going to become plus or minus 7i. Remember, the negative sign becomes I. 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 Alright, I probably have went too fast on that one, but if I did, slow it back just a little bit to get that last bit of answer. Alright, I want you to take a break, because that was a lot. Drink you some water, come back, and try this problem. Take a break, get a drink of water, come back, and try this problem. Welcome back. And yes, y'all, this problem requires an extra little step. So let's do it. Let's see, can you identify it, or did you do it? So we know for a fact the goal is to get x by itself. The goal is to get x by itself. The goal is to get x by itself. So we got some inverses to do. So let's take the additive inverse of 6 and turn it negative 6. My next step, for me to get that x squared by itself, I have to divide 6 by both sides. And when I do that, I don't know what's going on with this. You're going to get something like x squared equals negative 6 over 6. And yeah, I do apologize about what's going on here. It's just not showing what I need for it to show. So, what's negative 6 divided by 6? When you divide, you're going to get negative 1. So you're going to get s squared equals negative 1. So that's where my negative 1 comes from. Alright? But if I need to rewind, I can rewind it right quick. So let me rewind it right quick so you can see how I got to all that. But if you learn how to do this already, move on. But if you stuck on how I got negative 1, I will do that for you again. So I got 6x squared equals negative 6. That's what I did. I moved 6 to the other side. That's what I got. So what I did from there, of course, divide 6 on both sides. Because remember, x got to be by itself. So that's why I got this s squared equals negative 1. That's where that comes from. And of course, the inverse of square being x to the power of 2, the inverse of that is just the square root of x. So y'all, Can I have -1 in the square root? No. So what's gonna happen? The square root of -1 is what? It's just 1. And then negative sign, you put it in the back and turn it into I. And that is how you do that particular problem. Alright? So if you stuck on this, just rewind it. That's the whole point of these videos, is to rewind. So if you missed anything, just rewind it. Alright. Y'all just know, when you are doing math, when I give you an example, it's not going to be exactly step from step as what we did. The steps generally going to look the same, but I may give you a problem that requires you to think about taking the multiplicative inverse versus, taking the additive inverse. And remember, if I'm saying the additive inverse, for example, 6, the additive inverse of 6 is -6. If I'm saying the multiplicative inverse of 6, I'm saying 1/6 is the multiplicative inverse. Alright? So just keep that in mind. If you could keep that in track, you're going to pass. And do not forget, math is all about learning new material by bringing the old material mastered. Let me say that one more time, or you can remind it. Math is all about knowing the new material by using the old material mastered. So, I'm done. You guys have a good evening or a good day, wherever, whenever you're watching this video, and just take slow notes and get what you need.